Hello everybody, welcome to Dr.K.Liu Maths channel. This question, this is a funny question from DSE M2. Funny, so funny. Given a 3 by 3 identity matrix by I3, and I think I write it has I is only. It is better to use this not no need to use the indicator 3. And it is given that A is a 3 by 3 non-singular matrix such that A plus A inverse equal to negative I. Here, using mathematical induction to prove A to the power 2 to the power n plus A inverse to the power 2 to the power n equal to negative I. Here, I first let Sn be the statement. A to the power 2 to the power n plus A inverse to the power 2 to the power n equal to negative I for all positive integer n. And then for n equal to 1, I consider this take square on both sides of this the given condition, and that for this one it is equal to A plus A inverse. A plus A inverse. This is I. Right hand side is I. Then expand this matrix multiplication. A square. Square means A to the power 1, and A inverse to the power 2. And this one, which is I, this is also I, 2I. And move the, change the position of 2I to right hand side. Then it is negative I. Therefore, S1 is true. Assume Sk is true. That is A to the power 2k plus A inverse to the power 2 to the power k equal to negative I. Then for Sk plus 1, I take square on both hand sides of this. Take square. And the right hand side equal to I, and left hand side is A to the power 2k times A to the power 2k plus A inverse to the power 2 to the power k times A inverse to the power 2 to the power 2k. Oh, so crazy. And then for that I have also one term, that is this term times this term. And because two are the same, and I times 2 here. And for this one, that the power, the 2 to the power k, this power can be factorized outside. A times A inverse. Of course, if you know, you don't need to write down this step. But I'm here to present this step for the student who not very familiarized with such operation of matrix multiplication. Okay, this is I. This term is I, 2I. Move the to the right hand side, that's negative I. And for this one, A times A, that is the addition of the two index. Addition, I write here 2 to the power k plus 2 to the power k equal to 2 times 2 to the power k equal to 2 to the power k plus 1. Oh, crazy. It is so crazy. And then a to the power 2 to the power k plus 1. That is actually the statement of k plus 1. Therefore, as k plus 1 is true by mi, as n is true for all positive integer n. And the final step, it looks crazy. You see, find the value of this one. It looks like crazy. And a inverse to the power 2 to the power 100 and a inverse to the power 2 to the power 99 and until to a inverse to the power 2 and then a 2. I think you can group term by term. But I present here, I try to present here with a summation sign so that you can more understanding on this this question. And then for this one, I use summation sign k from 1 to 100, a inverse to the power 2k. And for the last, I use also summation sign k from 1 to 100, a to the power 2k. Okay, crazy, because the summation sign can be combined together and add them at these two terms together. A inverse to the power 2k plus a to the power 2k. That is actually negative I. How many negative I of this one? You can count 1 to 100. That is 100, negative 100 I. So crazy. It's very short, but it examines you the observation, how you observe the question, and if you observe that it have the pattern like that in part A, you are done. Otherwise, you will find this question is crazy. I can't think that I can do it, but actually you can. Okay. Okay, but anyway, I hope you can enjoy this video. If you found Dr.K.Liu Math channel is useful, please subscribe my channel. Bye bye.